Today we're talking about a new format of the definition of the continuity. And the reason why I say it's a new format because we probably have learned it before a long time ago in your calculus classes. However, today we're doing it in a different approach. The appearance of the definition may not be the similar to what you have learned before. We call it epsilon and delta format. But even though it looks different, you'll find it has the same nature compared to what we know before. So let's take a look. We use the notation of epsilon and delta to define the quality of a function on a certain position on the x-axis. And we say it's continuous if for all of the epsilon that are greater than 0. We can find some of the a given value of delta that are also greater than 0, such that the following condition is true. And what is a condition? Let me read it in English, even though I'm reading it in mathematical terms. So the difference between x, the general value of variable x, minus a fixed point x0, the absolute value is smaller than delta. And it implies that the difference of the output, which is f of x minus f of x0, is smaller than epsilon. It might be kind of abstract to understand without visualizing it. So here's a graph. You can see that if we make the y range very, very small, if we make the epsilon very small, then we can always find, no matter how small it is, we can always find a delta that are small enough to restrict the function into the certain region, which means that the function is always lying in such a small box that I'm shading here. This box can be extremely small, so that we can see if it's approaching 0, the size of a box approaching 0, that means the width or the epsilon and delta are approaching 0. Then it means it's continuous. So visually, we know the reason why it means the definition of continuity. So, notice, no matter how small epsilon is, I'm gonna just write it in Greek letter. It's kind of weird when I'm thinking in English and I'm actually writing in English. There is always a delta that guarantees f to be in the range of plus or minus epsilon. So this is what we derived from the format of the definition. And given this brand new definition, let's consider a very interesting example. Let's consider there's a function f that is mapping all the real numbers into real. And we can define it this way. F of x is x to the third power x cubed. And if we let x0 to be 2, and the question is asking you to prove that prove the continuity at x0. How do we do it? We do it by using the definition above. So we just start proving it. Let's look at what are we shooting for at this point. If we let like the definition, if we let epsilon to be greater than 0, then we need to find a delta. Alright. We need to find a delta such that the condition is true. And what is the condition? We just need to plug in the values given in a question into the format of the definition. So we can get the absolute value of the difference in the input smaller than delta is going to imply that the output difference is going to be smaller than the epsilon. And epsilon is fixed already because we already gave an epsilon greater than 0. Now we need to find a delta that ensures this condition is true. Now how do we find it? Now this is a test. We changed the proving test into a question or a test where we need to just find a very clear answer for which this whole sentence is holding. So if we assume that the premises is true, which is x minus 2 absolute value is smaller than delta, then how can we derive the conclusion? I remember we have a very basic formula you can search up online where you can get this conclusion is equals to x minus 2 times s squared plus 2x plus 2 squared, which is smaller than epsilon. And also, we have to know that because of triangular inequality, we can get that it is the whole thing is smaller or equals to x minus 2 times. Okay, we'll make a parenthesis right here. And also, we also know another fact, which is we make an assumption that x minus 2 absolute value that's smaller than delta that's smaller than 1. Make this assumption basically means we want to make sure the delta is very small. And 1 is a very easy point that we can reach and easy to calculate. So we just impose the condition of smaller or equals to 1 right here so that we can get absolute value of x is smaller than 3. And we can plug in this inequality into the equation on the right, so we can get right here, this part is going to be smaller or equals to 19 because we plug in 3 into absolute value of x. In this case, the whole expression is going to be simplified into the format of all right, I'm going to write it this way. Thus, we got smaller or equals to x minus 2 times 19. Because the whole expression right here is absolute value of the difference of the output. It is equals to this whole thing right here. And also it is smaller than the right part. So we just kind of like building them all together in order to find a certain delta that can make this equation inequality holding. And what should our delta be? The delta has to be smaller than a certain number. And what is this number? When you look carefully at this expression, you can see that we just simply need to build a bridge between first expression and second expression that I labeled right here. Now, how do we do it? We know as long as this expression right here, as long as it is smaller than delta, then we know this expression is holding. Because we already know inequality number 2, and now we need to find the relations between them in order to make sure 1 is holding. And after this, we see that we know that because we already made an assumption that absolute value of x minus 2 is smaller than delta. So of course we know that delta is smaller than epsilon over 19. And basically we're done. This train of logic is a little bit complicated if you never look at this type of question before, but hopefully you'll get it after you look at it carefully about the logic. A quick summary of the whole process. Basically, because we want to make sure it is continuous, because by intuition, we know already that at x0, which x is equals to 2, it must be continuous. And how do we justify and prove it? And we need to verify the definition. And if we can make sure the definition is true, then it is continuous. The way for us to make sure the definition is true is to make assumption of the premises in the conditional statement right here. After we make the premises, make the assumption of the premises, we need to find a relation between delta and epsilon, because the whole process is trying to find some of the epsilon that's holding, some of the delta that's holding. And as long as we find one delta or a range of delta, we're done because the definition is holding. And thank you for listening. I hope to see you guys next time.